I'm software engineer, DevOps architect at Stormeye, along with my colleague Ian Mills. We've been commissioned by Casper Labs to provide a scalable event store for events emitted by the nodes. So I'll dive straight in and give you a walkthrough of how we achieve this. The picture you see before you is a rather unflattering portrait from Dali of us two, but I thought it was quite amusing. So that's the Stormeye team according to Dali. Right, the problem space is that the nodes are emitting events constantly in the state machine, that is the chain, and these events fired off and need to be recorded. So you've got n amount of nodes. Each one is emitting nodes on 3 separate streams. You've got deploy, finality, and main events, and these need to be recorded and stored, and they need to be recorded in a timely manner and a way that we can trust. And also we had to factor in disaster recovery, fault tolerance, and how we were going to handle such a high load of events. So we looked into the Kafka option. It's an industry standard these days, developed by LinkedIn, believe it or not. And yes, there's lots of documentation out there. It's an Apache piece of software now. It's trustworthy. So how do you go about implementing a Kafka solution? So Kafka at the moment still uses Zookeeper for load balancing, for voting amongst itself for leaders, etc., etc. And you run what's called a Kafka broker. You can run multiple instances of these within an ensemble. And yeah, we set up local development prototypes of these and plugged in Java applications to add data and remove data, and more on that later. And yes, it worked. It was satisfactory. So the next question is, where do we put this Kafka cluster that we've got working? Well, how would it actually work? So upstream, you've got n nodes. You've got a Kafka broker sat in the middle. And what we needed to produce was a producer and a consumer. A producer will read from a stream emitted events from the nodes. We decided we'll wrap a little bit of metadata around this event, as in the URL of where it's come from, so the emitter, a unique key, a timestamp, etc. And then we can just pass this as a raw event into the Kafka brokers. Once there, it'll sit there and wait to be read until and then a consumer comes along, reads this message, and then processes it and do with it what it will. The Kafka brokers have a time to live for messages. Once they've been read, at the moment it's about 30 minutes they'll live there, and then they'll be deleted. As I said, once we've got this solution, how do we go about hosting it? So we went for a Kubernetes solution hosted on Google Cloud, G Cloud, which has come a long way from the early days. To me, it's the best solution out of the big three. So this is our final prototype version, which we had. As you can see, we've got n amount of nodes. We've got n producers, we've got n brokers, we've got n zookeepers. So in the end, for production, we can see that 3 brokers using 3 zookeeper replicas is satisfactory, and Kafka's got a very useful facility called consumer groups. So you can have two consumer groups or n consumer groups reading the same message. So once a consumer group is registered, the message will not be deleted until all consumer groups have read that. So in this diagram here, we can see that consumer group A is reading the message, the events in the broker, and passing them on to a Mongo audit system. Consumer group B is also reading the same events and passing them into a Mongo UI system. More on those data stores later. The good thing about this approach is that it's scalable. I'm using replica sets and deployments in Kubernetes. So at the moment, we say we can run 3 brokers. We can easily put that up to 5 or 7 if needed. The consumer group replicas running 2 or 3 at the moment. They can scale up, and with Kubernetes you can also scale the nodes it's running on. So you can handle a large amount of throughput. You can scale up the persistent storage in the back, and for a highly available scalable system, we thought that would be the best solution. And the final diagram, what we have at the moment running, is this one. So we have a single node at the moment, and a single producer. Stormeye have also developed the Java SDK, so we extended that quite a lot during this past few months to actually read emitted events. So that's now in the central Maven repository, and we use it in Gradle to download the latest version of the SDK, and this is used quite extensively throughout the project. It's been very useful. So as you can see, there's a producer sat there reading the raw events in. At that stage, it's also doing the last read ID. So if there's any failover at that point, Kubernetes will restart that producer, and it'll know then to start from from the last ID that it stored. So there's some disaster recovery already. So you got the raw event coming through, passing it through into the broker, and it'll sit there reading it. Kafka brokers very much go along the paradigm of topics, like most good message streaming services. So from a previous diagram, you could see there was 3 main streams: deploys, SIGs, and main. So there are topics, and we've got 2 consumer groups. We've got consumer audit at the top here, which, as the name suggests, is just a purely audit system, which will store the raw event, and this is stored in Mongo FS. So a raw event stored there, and yes, that is also used for any kind of disaster recovery. You can replay the streams using that audit API on the right, if need be, or if any downstream downstream clients want to replay events, they've got the option there. And at the bottom is the consumer store, again utilizing a lot of the deserialization of events that got written in the SDK. It's using them there to turn a raw event into a processed event. By processed event, I mean you're looking at deploys, blocks, transfers, withdrawals, etc., and you're applying any Casper business logic there, and they're all stored relationally in Postgres. Once there, we've got a store API, which provides endpoints for such applications as Block Explorer, block auditing, consensus monitoring, and I can show you the Swagger endpoint of that store API in a moment. For now, I'll just show you what Kubernetes is doing. So if we switch to Kubernetes here, we can see in the workloads the applications that we saw on the diagram there. So the main one, let's start from producer here. The producer is reading in events, and I can show you, this is in real time, I can show you logs of it actually reading events. So if we look down, this is my time now. So we're processing event there, we've sent a topic, deploys, partition, etc. So this is actually happening now. See, the more events have come in just then. And if we have a look at a consumer, we've got the store consumer as mentioned in the previous diagram. This will be reading these events. Again, we can look at the logs, and here we have block added, some transfer events, a deploy event, and if I open up the details there, we can see this has been added to Postgres. So that's our store, and the various other important pods are here. So we've got Zookeeper and the Kafka brokers. We've got Postgres and Mongo. So data stores live on the cluster. That gives us a lot of scalability. A lot of we trust Kubernetes. It keeps the pods alive. The Mongo events, you can see there's two pods of that. One's master, one's replication. We've got two instances of Postgres. One's master, one's replication again, and that's Kubernetes ticking along nicely. That's a lot of work's gone in to get this Kafka broker, Zookeeper, producer, and the consumers all talking to each other. And if we have a look in Swagger to look at our endpoints, we can see this is the current endpoint of this. We can see all the endpoints I've mentioned. If we have a look at deploys, we can try it out, and we can look at all the deploys that have been coming in. And this has been running for 2 weeks now without being down. We can see we've got 15,000 deploys sat there. This is connected to a LiveNet node, and we could scroll up and have a look at blocks. How many blocks we're getting through? So we'll go to blocks here, try it out. Again, we can see a lot of data passing through. Yeah, we've got 36,000 blocks there, and we can. There's various endpoints, standard, REST. You can go by block hash, deploy hash. You can look at transfers for individual. More endpoints have been added to this all the time, and we've got validators and transfers. To get to this, what's interesting, there's 3 main repos. We'll look at the. They're all in the Stormeye. Well, one of them or 2 of them are in the Stormeye 2000 GitHub repo. We see we've got a busy main branch here of the events store, and in this we can see all the sub projects like the audit API and the store API, the producer. It's a Gradle Java 17 project. This is well documented. The code is being passed through Sonar to get here. I've made a note here on how we're doing this. We're getting good 85% plus code coverage. We're using Sonar for each merge. I've also there's lots of documentation here. So that's the Java code. Within here also we've got the how we get to the cluster. So again, this is well documented. There's within here the multiple brokers stateful set. I've given detailed documentation of how to replicate this, how to set it up. It's quite an involved task. And in here you can see we've got, for instance, a dev, we've got all we need, and we've got YAML files here, for instance, is how we set up the Kafka brokers. And we also have the SDK, which Stormeye 2000 worked on along with a company called Synthify. This is extensively used, as I say, throughout this event store, because we've written all the deserialization of the CL types, and we didn't want to replicate Sode's code, so we're just using this. Again, this is well documented. It's up there on Maven repository, and that's that. Okay, so there are Medium articles as well that go with this, and that's an overview from Stormeye of the event store. Thank you very much. Bye.